Welcome to the tutorial on how to find the y component of the gravitational force, or what we call Fg perpendicular. Alright, so the first thing that we need to know is that Fg, right, equals to mg, which means mass times the gravitational acceleration. And we must always know that the gravitational acceleration is always, all the time, 9.8 meters per second squared. All right, so let's look at our diagram over there. Okay, so the diagram that is showing mass m, and we are having an incline over there with the angle theta. All right, so now how can we find the perpendicular component of gravity on that diagram? Okay, so the first thing is we want to draw a diagram, a nice diagram that, all right, so first thing, draw a nice line that is parallel to the surface of the incline. Okay, after you've drawn that, then you're going to draw a dot that is representing the mass, and then afterwards draw a line that is actually a line that is, okay, so I'm gonna do, so you want a line that is, okay, you want a line that is perpendicular to the surface. Okay, so I think I did it wrongly there. Okay, so you want a line, so let's do this. So we want a line that is perpendicular to that surface. So okay, so there is a line that is perpendicular to that surface, so we draw it like that. Okay, and the line perpendicular to the surface, already we know and we can label it, that's the Fg perpendicular, right? Then what you do is afterwards you're going to draw a line again, and this line is going to be parallel to the page. Please remember, parallel to the page and not parallel to the surface. So this line parallel to the page, that's going to be your Fg. Okay, it's because it's always directly downwards. Okay, so that's Fg, always directly downwards. All right, and the angle of the incline needs to be placed between those two. So the angle of incline, which is theta, is going to be between, or rather is always between Fg perpendicular and Fg. And of course, you do have on that same diagram, if you complete the triangle, you do have Fg parallel, which is also referred to as FGX. All right, so there's a 90 degrees between Fg perpendicular and Fg parallel. Okay, so now because of that, we can now come to making mathematical definitions. All right, you can see that your gravitational force Fg there has now become the hypotenuse, right? The hypotenuse of that triangle. All right, and Fg perpendicular is the adjacent of the triangle, and Fg parallel is the opposite of that triangle. So we can write it like this. We can say Fg perpendicular divided by the force of gravity is going to be equal to the cos of that angle, right? Using our math, and resolve it to, so that means Fg perpendicular is therefore equals to Fg, original gravitational force, cos of the angle. Right. So we can finally say that, okay, since Fg is mg, we can finally say that to find the perpendicular force of gravity, you need to take mass times the gravitational acceleration multiplied by the cos of the angle theta there. Okay. Now, we can do the same thing for the perpendicular. We can do the same thing for the parallel force. Okay, so if you look at that, you can say, okay, Fg parallel over Fg, which is your hypotenuse, equal to the sine of the angle. Okay, because we can see that this is opposite to that angle. Okay, so it's directly opposite to that angle, and it's just visible there. So we can conclude here as well that your Fg parallel is equals to, right, Fg sine of the angle theta, which is basically mass times gravitational acceleration sine of the angle theta. All right. So now that we've done that, let me just take these others downwards a little bit. Okay, so that I can have a bit of space. Okay. So now that we've done that, we can come up with a general formula that when you calculate the y component and the x component, or rather the perpendicular component and the parallel component of gravity, right, then these are the formulas for Fg perpendicular. This is equals to mg. Okay, so this can now be your shortcut instead of you drawing the diagram each and every time. Okay, and then obviously again we can say that parallel would therefore be equals to mg sine of theta, and that defines that. Okay, so we've done so well to this point. Right, now let's start calculating the y component. Okay, so calculating the y component, we're going to be using what? The formula for Fg perpendicular. All right, let's look at scenario number A. All right, if we draw, okay, free body diagram, so we will draw it like that. Okay, so I'm only going to draw the force of gravity and its y component in this case. So force of gravity, right, so obviously if that's the surface, let me show it there. If that's the surface, then it means that the perpendicular, the force that is perpendicular to that, we always write perpendicular and downward. That is your Fg perpendicular. Okay. Now, right, so if we have, okay, that, then now we need to say, okay, what is the angle of incline? Okay, what is theta for that? It's a horizontal surface. So for every horizontal surface, theta is equals to 0 degrees. Okay, so since that is the case, we can say that that component over there is going to be mg, right? We know that it's mg cos of the angle theta. All right, in that case, that's going to be mg cos of 0 degrees, and we know cos of 0 degrees is 1, which means it's just equals to mg. So fg perpendicular when the surface is horizontal is basically just equals to mass times gravity, which is basically just equals to fg. Okay, the original fg. All right, and then why is that? And that's because the angle is 0. All right, and that's why most of the time on horizontal surfaces, you only just see the force of gravity represented there, and we don't even have to break the force of gravity into components. All right, so for that, you would have just said mass of 5 times 9.8, and that will give you 49 newtons, and that will be down. So let's look at number B there. Okay, for number B, we will say, okay, let's draw a force perpendicular to the surface and downward. Okay, and we're going to name it FG perpendicular. And we know that FG perpendicular is basically mass, right? And then cos of the angle theta. Then this is going to be equal to, right, obviously this is a horizontal surface, so theta is equals to 0 degrees. So same like last time, mg cos of 0 degrees, right, which is basically just mass. Cos of 0 degrees is 1, so it's going to be mass times gravity times 1, which is basically the mass is 10, the gravitational acceleration is 9.8, and all of that will give us 98 newtons downwards. Okay. All right, I hope you can see that this is easy. And then let's look at C. Okay, so for C there, we want to find the y component of force of gravity. So we know that we don't have to do much. We already know the formula, which is mg cos of the angle. All right, so since we know that, and that means we can now say that this is equals to mg, okay, mass, which is in that case 10, force of gravity, which is 9.8, cos of the angle there is 40 degrees, and then you can take your calculator, all right, and do that, and say cos of that angle of 40, right? So your calculator should be giving you something like 75.07, and that's Newton, and that is obviously um, down perpendicular to the surface. So if I may draw it there, so perpendicular to the surface, that's that direction. So that will be the y component of fg. Okay, so there we go. And then for d there, Okay, same thing, right? FG, the perpendicular, is equals to mg cos of the angle, which therefore is equals to, in that case, mass is 100, gravity is 9.8, always cos of the angle there is 30 degrees. So it doesn't really matter which side is the angle, and that will be equal to, all right, so you should be getting in this case, right, you should be getting something like 848.7 newtons, and that's obviously down, perpendicular the incline. Alright, so basically that is how to find the y component of Fg, which in turn will end up helping you find the normal force, which in turn helps you to find the, obviously, the frictional force. Okay, so that is it for today. Okay, so if you have any question, do put it in the comments, and if you like this video, give it a like and subscribe.